Welcome. This lesson is over how to order rational numbers. So before we do that, let's look at our number routine. Our number routine is about alike and different. Write down two ways these numbers are alike and two ways these numbers are different. I'm going to make myself a T-chart. The left column will be alike. The right column will be different. Well, what I can see different is I see different denominators. Sorry, it's denominators. I see different types of rational numbers. I see fractions. I see decimals. Alike, these are rational numbers. Rational numbers are numbers that can be written as in the form of a over b, or as with a numerator and with a denominator in fraction form. For example, can I write this decimal in fraction form? Yes, I can. Using my place value, this is 28 hundredths. Could I simplify that? If I divide both numbers by 2, I get 1450. And if I divide both numbers by 2 again, I get 7/25. Hey, these are equivalent numbers. 1450 and 7/25 is equivalent to 28 hundredths. Again, I could think backward. If I'm given the fraction 7/25 using place value of hundredths, what is the relationship from 25 to 100? Scale factor times 4, so it is 28 hundredths. So in this activity, you will be given, each try will be given this question. What you're going to be doing is you are going to, using a variety of strategies, can you solve it? So Grant measured the height of some of the cars of his miniature train set. The engine was 9/10 inch tall. The coach was only half tall. The box was measured 3/4 inch tall. This should be inch tall. And the caboose was 3/5 inch tall. Grant lined up the train cars from tallest to shortest. Explain through pictorial model and or arithmetic your reasoning. So you have the four rational numbers of 9/10, 1/2, 3/4, and 3/5. How are you going to solve? So it says use a pictorial model. That means I already have it right here. I can use fraction bars, fraction rectangles. Maybe you are more comfortable with fraction circles. So 9/10. I'm going to divide this into 10 parts. And I'm going to shade in 9 of them. Next one, 1/2. I'm going to cut this into 2 equal parts and shade in 1/2. As you can tell, 9/10 is greater than 1/2. Next one, I'm going to divide this into 4 equal parts and shade in 3/4. As you can tell, 9/10 is still greater than 3/4 and 1/2. And last but not least, I'm going to divide this into fifths. And I'm going to shade in 3/5. So which one is the greatest of all? From what I can tell, 9/10 is shaded the greatest amount. Then it seems like 3/4 is shaded, second greatest, then 3/5, and then 1/2. And that's how I could do it with the pictorial model. Some of you may be comfortable with that. Some of you may think that is the greatest thing since sliced pie. However, what about using arithmetic or estimation skills? Let's use estimation skills. Well, let's see. All of these fractions are more than 1/2, but half is half. 9, if you think about it, in elementary school, you may have learned this. You have a denominator 10. 9 is closer to 10. So that's why this is greater than 3/4 and definitely greater than 3/5. Because you have 3/5 is just a little more than half. That's why it's just a little more, while 3/4 is greater than 3/5. So we can use through estimating skills. Another way you do it is some of you may prefer turning into decimals, because we did spend 2 days learning decimal. Let's start at 9/10. Using the place value of 100, what's the scale factor from 10 to 100 times 10? So that is 90 hundredths. Next one. Using the scale factor, how do you turn a 2 to 100? What is the scale factor? I'm going to multiply it by 50. So that's 50 hundredths. Using the denominator place value of 100, what is the scale factor from 4 to 100? Times 25. So that's 75 hundredths. Using the denominator place value of 100, what's the relationship or scale factor from 5 to 100? Times 20. That would be 60 hundredths. So 90 hundredths is the greatest, then 75 hundredths, then 60 hundredths, and the smallest is 50 hundredths. Hey, so that's another way you could have done it. So 9/10 is the greatest, 3/4, 3/5, 1/2. And the last way, so we have pictorial model, estimating skills, decimal. Last one is least common denominator. In elementary school, you did learn something called least common denominator, when you had to add and subtract fractions. So what denominator do 10, 2, 4, and 5 all share in common? Let's see. 10, 20, 30. 2, 4, 6, 8, 10. Oh, 10 is what they share in common. But 4, 8, no, 4, 8, 12, 16, 20. 5, 10. Well, see, this 4 will not go into 10. 5, 10, 15, 20. I believe they all share 20 in common. That's the least common denominator. However, a common denominator is 100. They do all share 100. So you can use that if that is what you are more comfortable with. But I want to do the least amount of work, so I'm going to find the least common denominator. So what is the scale factor from 10 to 20 times 2? That's 1820. So 9/10 is equivalent to 1820. What is the scale factor from 2 to 20 times 10? That's 1/2 is equivalent to 1020. What is the scale factor from 4 to a 20 times 5? That's 1520. 3/4 is equivalent to 1520. What is the scale factor from 5 to 20 times 4? That's 1220. So 1820 is the greatest. So 9/10. Then 1520 is the second greatest, 3/4. Then 1220 is the third greatest, so that's 3/5, and the smallest is 1020 or 1/2. So what do you prefer? Which strategy? I do not expect you to do all four of them. I don't expect you to do pictorial, decimal, turning into a decimal, least common denominator, or estimating. You choose which one you think is easier for you. However, there are some questions, depending on the rationale, that lends itself to better strategies. For example, this one. Put these rational numbers in order from least to greatest. So, would you like to draw 7, 8, 5, 6, 3, 4, 5, 12? Ugh. I could if I want to. Do I really want to draw a rectangle and cut it into 12 parts and shaving? I can if I want to. I can if I want to. However, would I like to turn it into a decimal? I could. But then 8 does not go into the place value of 100 easily. That means I would have to divide. I would have to do 7 divided by 8, or 7 divided by 8, and this one I would do 5 divided by 6. Would I like to estimate? I could, but 7, 8, 5, 6, 3, 4 are really close in estimating. Actually, this is negative. However, the best one lends itself, I think finding the common denominator is easier, in my opinion. What does 8, 6, 4, and 12 all share in common? 8, 16, 24. 4, 6, 12, 18, 24, 4, 8, 12, 16, 20, 24, and 24. So what is the scale factor from 8 to 24? Times 3, that's 21, 24. Times 4, scale factors times 4, that's 20, 24. So 21, 24 is the largest than 20, 24. Scale factors times 6, so it'll be negative 18. And this is times 2, negative 10. Don't forget these negative. Let me highlight that in case you did not see that. Because I have kids always miss this because I didn't see the negative. So they all have a common denominator of 24. Now let's put these numbers from least to greatest. Think about it. This is a number line. Well, this is a number line. Here is 0, our benchmark number. Which one would be which integer right here would be the left side of 0? It'll be either negative 18 or negative 10. But which one will be more left? Negative 18. So negative 3/4 is the least. Then negative 5/12. And then which one is closer to 0? 20, 24 for 21, 24. 20, 24, so 5, 6. And then 7, 8. That is how I put them from least to greatest. I use common denominator. I could have used decimals. If I divided 7 divided by 8, I believe that is 875,000. 5 divided by 6, I believe that's 833 repeating. If I divided 3 divided by 4 or go to place value, that'd be negative 750,000. And I have no idea. That's a little less than half. So I'm going to say like negative 400 something. So negative 750,000 is farthest away, farthest left from 0, then this one, then this one, then this one is the greatest. So what you're going to be doing now is something called clothesline mathematics. I'm going to hand different students a card. And in the front of the classroom, there's a long clothesline, for example, like this. So here's a clothesline. You're going to put them in the correct placement. However, make sure you be aware of spacing. So let's start with our benchmark. 0, 1, and half goes in the center. Is this halfway? It is. So make sure my spacing is correct. You would have a little measuring stick to help you with the placement. All right, let's look at first. 1/3. 1/3. There's many ways to solve this. You can use pictorial model. You can use decimals. You can use least common denominator. It's what you choose. If I think about it, 1/3, this is 1/2. 1/3 is less than 1/2. I don't know why this, oh goodness gracious. 1/4. If I draw 1/4, I believe 1/4 is less than 1/3. It goes right here. 5/10. 5/10. Can I simplify? Divide by 5, 1/2. So 5/10 is equivalent to 1/2. 75/100. Well, that's closer. That's between 5/10 or 50/100 and 1 whole. Ooh, 5/2. Well, first of all, this is a improper fraction. So if I turn it to a mixed number, how many 2's go in 5? 2 times. 5 divided by 2, it goes 2 times. You have 1 left over, so 2.5. So I know that one is the greatest of all. And then 1 4/5. Is 1 4/5 a little less than 2.5? It is. And that is how I put it. As you can tell, there's not really a lot of room here. If I was doing this with on a board, there'd be a lot more room. So So the least is 0, 1/4, 1/3. These two are equivalent. 7,500, 1 whole, 1 4/5, and 5 half, which is 2 1/2, or 2 5/10. Let's try another example. So let's put our benchmark 0 down here. 1 goes here, and 1/2 goes here in the center. 13/20. I'm going to use some estimating skills. 13/20. Is that a little more than half? Because half of 20 is 10, so I know it goes right here. 7/10. All right, so this is where it gets a little confusing. All right, let's look at 7, 10, 13. I could draw a rectangle and cut it into 10 parts, a shade of 7, and this one 20 parts and color. But I want to use a common denominator. 7/10. How do you turn 10 to 20? Times 2, that's 14/20. So 7/10 is just barely bigger. Even if I try to estimate or draw it, it's going to be very hard to distinguish the difference between these two rational numbers. That's why sometimes it's good to use mathematics. 8,500. Well, 7/10 we know is this as a decimal. So we know 85 has to be a little more than that. I'm going to scoot this down a little because I just don't have any room here. 65 hundredths. 65 hundredths. If I simplify this, I divide both numbers by 5, and I get 13/20. Oh, 6,500 is equivalent to 13/20. So we have 1/2, 6,500, 7/10 or 7,000, 8,500, 4/5. 4/5. Would I to turn that to a decimal? I'm going to use place value then. Times 2, scale factor times 2 is 8/10. Well, 8/10 or 80/100 is a little greater than 7/10, but smaller than 8,500. And then last but not least, 3/4. 3/4. So here is our rectangular model. So 3/4 looks like this. So I know it's more than 1/2, more than 6,500. I'm going to use place value in order to turn this into a decimal. Times 25 times 25. I get 75 hundredths, which is right here. Another way you could have done it is using the least common denominator. What does 20, 10, 4, and 5 all share in common? 20. So we know this is 14/20. This is 13/20. 3/4. If I build it to 100, to 20, I mean, times 5, that would be 15/20. And 4/5, if I build this to 20 times 4, that would be 16/20. So 13, 14, 15, 16, 20. All right, next one. Here's our last example. We have 0, 1, and -1. Dun, 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 dun. So 33, positive, 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 negative, negative. Do I want to turn these into decimals? Do I want to estimate? How do I want to do this? I could estimate. 1/6. That's a little less than half. So that goes right here. Because half would be, -1/2 would be right in the center. This is a little more than 1/2, so it goes right here. That's the one way I could have done it. Another way I could have done it is using common denominators of 6. Scale factors times 2. That's -4/6. -4/6 is lesser than -1/6. Next one, 1/3, 3/2, 5/6. Well, first of all, I know 3/2 is more than 1 whole. Isn't that just 1 and 1/2? In case you don't know why, can 2 go in 3 one time? You have 1 left over, 1 and 1/2, or 1 and 5/10. So we're left with 2 of them. Well, 1/3 is a little less than half. So I'm going to closer to 0. But 5/6 is way more than half, so it's closer to 1 whole. So it goes there. And 1/3. Let's think about it. If this is 1/3, and I divide 1 into 3 equal parts, what decimal would go in each one? 1/3. So give it one whole, cutting into thirds, that would be 33 hundredths. So these are equivalent. So there are many ways. I could have done pictorial. I could have done estimating. I could turn it into common denominators. I could turn it into a decimal. There's no right or wrong answer. It's just what you think is the perfect strategy for yourself.